Ambiguity sucks. The English language is rife with ambiguities, and I couldn't imagine having to learn it as a second language, given that it breaks its own rules all the time. I before E except after C, right? Well, consider this paragraph I just threw together. They love caffeine and leisure, albeit their love for science outweighs both. Neither of them is weird enough to combine all three activities. If they tried, their efficiency at one task would suffer. They should, in good conscience, forfeit any hope to do all these actions simultaneously. Each of those highlighted words breaks the I before E except after C rule in one way or another. So what about words with multiple meanings? I mean, if we're going to communicate properly, we need each word to have a unique meaning, correct? Well, take the word set. Ready? Set? Go. You could set the set of tableware down while you watch the TV set, or if you broke your arm during the last set in a tennis match, you could have it set while you watch the paint set. Or, if you're all set to go, you could go watch your favorite band's latest set, but the noise will likely set the neighbor's dog to barking, and on and on. What about prefixes? There should be a clear set of rules there, right? Well, sane, insane, experienced, inexperienced, equality, inequality. So far it sounds like a lack of a trait means that we should add the prefix in. Let's try it out. Tom was not the popular guy in college. In fact, he was so unknown that you could say he was infamous. It wasn't that he didn't like people. He was just unmotivated to go to school. His parents didn't want him to be uneducated, and he didn't want to appoint them. So he paid his friend to take classes for him. One thing you can't say about Tom, he is definitely not endeavious. Double not negative intended. That just sounded terrible. Maybe I'm too ingenious for English. Wait, does that mean I am or am not a genius? To be fair, mathematics has a few huge ambiguities that I professionally take issue with, and one of them centers on this notation here. Is that a point? Or is it an interval? Is that the opposite of a terval? Honestly, context will often give us the answer to this question, but let's do the opposite of investigating and investigate this mystery.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, I will review interval notation. We're not going to bother with solving things here. Our focus will be squarely on solidifying our understanding of intervals and interval notation. So let's get started. From our math background, we know that we can create sets of objects using roster notation. For example, the set of the first 5 natural numbers is this. The set of the first 5 prime numbers is the following. By the way, note that 1 is not a prime number, so you don't include that in that list. The set of all integers starting at -1 and ending at 100 is this list right here, where the ellipses are used as a notation to tell us that a set pattern continues. The first 3 terms in the set went from -1 to 0 to 1, so the pattern looks to be adding 1 each time. The ellipses allow us to assume that this is the case all the way up to 99 and 100. In each case, we list out the elements, or a pattern for the elements, and enclose them with braces, also known as curly brackets. However, what do we do if we're asked to list all numbers between -1 and 100? Since we were not told to only consider integers, we must include fractions like 1/2 and 37/11ths, along with irrational numbers like pi and 17 divided by the square root of 2. There are an infinite amount of these numbers between -1 and 100, so we need a more convenient notation. It would take us forever to list out all the possibilities. Enter interval notation. Before we get too far, we must recall that there are 2 types of notations with interval notation: the parentheses and the bracket. Brackets are used if the endpoint, or the edge number, is included in your interval. This is called inclusive notation. Parentheses are used if the endpoint is not included. This is called exclusive notation. Here is the definition. Few things I need to mention here. A being less than B is a requirement. The exclusive notation, parenthesis A, comma B, end parenthesis, is also known as an open interval. It's open because it's open at the endpoints. You're not containing those endpoints. Then you have these two other cases. Both of these cases are called half-open intervals. It's because each of them has a parenthesis on only one of their endpoints. This final case is called a closed interval, and this is because both A and B are included in the interval, and we call that in mathematics a closure of the interval. The first notation, the parenthesis A, comma B, end parenthesis, is the ambiguity mentioned in the opening of this video. Without context, the notation parenthesis 1, comma 2, end parenthesis, could mean the ordered pair 1, 2, or the exclusive set of all numbers between 1 and 2. Luckily, the distinction should be obvious based on the activity you're engaged in at the time, so you don't really need to worry too much about it, but it is an annoyance that they share the same notation. Finally, it is incredibly important that you realize intervals go from left to right as far as a number line is concerned. That is, the first element, A, in an interval is always less than the second element, B. Students often write this backwards. For example, I will see students write the interval like this, and it makes no sense mathematically. If you are in one of my transfer level math courses and you make this mistake, well, it won't be good. Let's make up a few examples and build some intervals. The set of all numbers starting at -10 and ending at 20, including both -10 and 20. First, we note that -10 is less than 20, so the order should be -10, comma 20. Now we need either parentheses or brackets. Since we're told both of these endpoints are included, we choose brackets. The set of all numbers between pi and square root of 2, not including pi, but including square root of 2. If you're not familiar with the size of pi or square root of 2, you might have to grab a calculator to compare these. But square root of 2 is less than pi. Thus, the order is square root of 2, comma pi. Since the square root of 2 is included, it gets a bracket. And since pi is not included, it gets parentheses. All single-digit positive integers. Now this is a trick question. Why? Well, here's a list of all single-digit positive integers. You see it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no way to use interval notation to capture this group because interval notation would include all numbers between points. That is, if you use closed brackets, 1 to 9, well, this would include 1.3 and 5.77678 and stuff like that. The only way to write this group is to use the roster notation, an interval representing all possible ages that my students could be. I might be wrong, but I think the lowest age for a college student is 14, at least on my campus. However, there have been rare exceptions in the past, and I'm just going to say that 14 is the youngest just for this example. As for the oldest, as of today, Kane Tanaka is the oldest person in the world at 116 years young. Since she is welcome to take my class, I will include her in my interval. So as of today, the interval representing all ages my students could be is 14 to 117, where we include 14 because I have to include a 14-year-old in my class, and I go all the way up to 117, but first of all, why do I use 117, not 116? And why is there a parenthesis and not a bracket? So let's take these as two separate sub-questions. First, why an interval, actually? Some students would ask, well, isn't this like the last example where we needed roster notation to get 14, 15, 16, and so on and so forth, all the way to 116? Nope. A person is exactly 14 at one single moment. After that, they are 14.0000001 years old. And roughly 8 months later, they are 14 plus 1 over the square root of 2 years old. What I'm trying to say is that our age is continuously flowing through time and is not discrete units. Therefore, an interval is best to use to represent all possible ages in my classroom. Second, why doesn't the interval stop at 116 and look like this? Well, this is because this wouldn't allow Kane Tanaka to take my class. She's actually 116 years, 178 days, plus some number of hours, minutes, seconds, nanoseconds, etc. old. She's older than 116 years old. So, to be cautious, I chose this interval which covers her throughout her 116th year. Technically speaking, all intervals are infinite because they contain an infinite amount of numbers. However, when we say infinite interval in mathematics, we truly mean that one or both sides of the interval just keeps going on forever. The symbol traditionally used to represent the concept of infinity is the lemniscate. It looks like a sideways 8, and that rhymes. It's incredibly important to note that infinity is a concept, not a number. Moreover, because it's a concept, you can never actually grab onto it. Therefore, intervals with infinite endpoints will never include those infinite endpoints. That is, all numbers greater than 5 would be denoted 5 to infinity with parentheses on both endpoints. First, notice the order. 5 is definitely less than infinity, so it belongs on the left side of the comma. Second, using a bracket on the infinity would not make sense because you'd be claiming two mythical things. One, that you can grab onto infinity, and two, that there's no number greater than the infinity you just grabbed. However, as all school children know, I love you infinity always gets beaten out by I love you infinity plus 1, which gets beaten out by I love you infinity to the infinity times infinity, ad infinitum. Let's try another quick example. All numbers less than or equal to pi over the square root of 11. Well, this would be the following. Pi over the square root of 11 is going to be the largest number we will consider, so it goes to the right of the comma. We're allowing all numbers less than this, even very negative ones. Therefore, this interval includes all numbers on the number line to the left of pi over the square root of 11, forever and ever, all the way down to negative infinity. Remember, it doesn't include negative infinity because that's just a concept. It's a representation of this number line going on forever. Finally, if we want an interval that includes all numbers, we want it to go as far as possible to the left on a number line and to the right as well. That is, all the way down to negative infinity and all the way up to positive infinity. And remember, you cannot include infinities, so therefore our interval would look like the following. The most common mistakes associated with interval notation are as follows. Using the wrong order. That is, instead of writing the interval from lesser to greater, I'll often see students write intervals backward from greater to lesser, like the following. This is a terrible mistake, and if I see it in a transfer level course, I take a considerable amount of credit away from the student's score for that problem, and I suspect that your instructor would as well. Using the wrong edge symbols. That is, using a bracket when it should have been a parentheses, or vice versa. This is actually really common when students use infinity. I'll see the following and will mark off significantly for this lack of understanding. Remember, infinity is a concept, not a number. As such, you cannot include it in an interval because you cannot distinctly grab it. Thank you for watching this review video on interval notation. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar or if it was confusing to you, then I recommend you click on the provided relevant prerequisite links listed below for further help. However, if you find you're continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. doesn't justify you to speak too loud and cry.